are ready for our next keynote speaker. The topic is the AI revolution in the making. We have Dr. Shekhar Mishra, who has been working with Fermilabs for a long period of time. I know you didn't want me to mention it, but I can't avoid it. Like I used to work for IBM, I can't avoid that history that I have behind me. But we're glad to have Dr. Shekhar Mishra here with us. And he has been working on your company called Quark to Quanta LLC. And we'll give you a great talk on AI revolution in the making.
Okay, thank you for your invitation to give this presentation. So you can say Fermilab. Fermilab can't get out of my blood. But I do not present or speak on behalf of Fermilab at this meeting, because if I do, then this slide has to go for approvals. And so that's why I say I do not represent Fermilab and do not represent the United States Department of Energy while I'm giving this presentation. And this company, just because that way allows me to speak my mind. So, okay, anyway. So, in the slide there is a history thing which I will skip. So my journey in the development of AI and relation with India, it started with this statement from my dad. Is देश के लिए कुछ करो. He was the one who, so he said that in 2003, and since then I have been working both in India and United States towards the development of science and technology. And I'm very thankful for both the US and Indian government for supporting this initiative that we started in the United States. And after 3 presidents and 2 prime ministers, we have several agreements that you can look at on my website. And if you ever want to collaborate with India on science and technology, the agreement of 2005 is the key one you should look at. So we have been trying to make my dad's statement a reality. So if I tell you the evolution, I have to tell where we are going, I have to tell you the history of how we got here. So this is my personal journey of computing in the world. I don't know how many of you have used that punch card. Maybe a few. That's where the computing in the United States used to be, 1980s, early 90s. And the picture on the right is NVIDIA Grasshopper 200. This is the first machine ever came out of NVIDIA to be used at a national lab. And I had the great honor of using it in our deep neutrino experiment development of AI. So you can see that I have passed through the whole generation of computing over the span of about, and I will just tell you where it's going by telling you where we are in this technology. All of these technologies are developed jointly with the US and international laboratories and our industrial partners together. But most of this driving force is, at least in my opinion, has been developing the chip technology or silicon technology. And the driver of that technology has been essentially particle physics and astrophysics, to the best of my knowledge. So, early implementation, most of the people know about AI after ChatGPT and Copilot came out a couple of years ago. But we have been using AI at Fermilab since the early 2000s. It was used just after the discovery of top quark in 1995. We call it neural network implementation, which is essentially the same that people call it CNN these days. And because of the huge compute power, there are a lot of more fancy things you can do. But the principle that was used in neural network implementation for top quark or bottom quark physics is roughly the same. The next thing on the right in this picture. Yes.
Hello. On the left is one of the accelerators that I help build, design, and operate. But in the AI implementation, again, don't call it AI. It's a digital twin application. This is a 3.3 kilometer accelerator at Fermilab. It has more than 1,000 components and a couple of hundred sensors, and it produces one of the highest energy proton beam in the world, and it is used today for neutrino experiments. One which will shoot beam from Batavia all the way to South Dakota. But the main reason I put this thing there, that an early version of AI was implemented here, which we call a digital twin, that in the case of either that you have a machine or you have a computer model, and you cannot tell the difference between on one or the two while you are operating this machine. So this thing, compared to those days, compute powers have gone up quite a bit. So moving forward from 2000 to today, I said that most of the thing has to do with silicon technology. So silicon microstrip detectors we used to have of about 50 micron in size. These days we can make it 1 micron, and traces can be put on there with 1 nanometer or 2 nanometers the last I checked. So you can literally put a lot of information on 1 millimeter by 1 millimeter chip. We could not do that in 2000, and you will see how this evolved. And there is a direct correlation between the evolution of the silicon technology and evolution of the GPU technology. It has almost followed each other in parallel. So what you see in this graph is the evolution of this. At least I'm not moving it. Sorry. Evolution of the silicon technology from 1980s to, unfortunately, I don't have a pointer to show you but you can see the green curve is going up. There was no GPU at that time. When we got to pixel scale, then GPU started. First one was Geoforce, then Tesla style, then amperes, and now when we can do about a millimeter, 1 micron technology, we have this GH200 out in the market. And you can see that it's every time there is a new GPU, it follows the new silicon technology. And those silicon technology are all used in high energy physics or in astrophysics. So they are the one who's driving TSMC in getting it smaller and smaller and smaller, because that's where the speed comes from. So I will not bore you with the detail. You can read through it. But on the leftmost side is the different incarnations of artificial intelligence in the computing world. And no, I don't need that. That will be even more complicated. I don't know how to give bhasan. So the new capabilities came, and my focus has always been in physics. But in the parallel, the medicine comes and finance, where AI is going to become the biggest driving force for the future. So I wanted to give you an idea of where we are heading, and I will say something about it later. So anything in red has myself and my colleagues involved in the implementation of AI in particle physics or in accelerator. And you can, I don't like to say Google, but you can use any search engine and find them in detail. So, problem is I cannot see over there and over here at the same time. Okay, so again, my focus is to really drive into you where the technology is heading, and in the opinion of silicon technology, it is kind of plateauing out. That you see, you can follow any of the curves. The red line is the silicon technology, which has been becoming smaller and smaller. And any of the blue, yellow, or green line is how the chip industry is growing. And you can see that when we went from microstrip to pixel, there was a big change in the GPU power. And now it has kind of plateaued out, and it requires some new innovation in the silicon industry to move this GPU industry. And this is yet another way of presenting the same thing, but on the second y-axis, you see the different GPUs that has been coming out, and unfortunately, I'm having a real hard time seeing it, my own graph. So, in both of these cases, you can see, sorry, I'm used to pointers, that the chip technology has, in the GPU era, has really showing a sign of growth, but plateauing at the same time. And this is where I want to point out that both at least to my knowledge, somebody else may be spending money in it, but high energy physicists and astrophysicists who drove the chip industry to go smaller, the silicon industry to go smaller and smaller and smaller, right now is not spending any money in that R&D, because we already have the detectors we need. And as you know from the US government and international funding of science, it's in a very poor shape. So pushing this technology requires real industrial investment. And you see that there are some of the chip companies coming back to the United States, but who's going to drive them is a question. Okay, who's going to make them smaller in size and more powerful? The biggest advantage in all of this computing has been, over the last 2 decades, has been that the cost of running a computer has come down about hundreds of million times In the early days, one CPU with almost no power, maybe was taking half this room. Now you carry a thing on your iPhone which is more powerful than the computer that went to 1969 to Moon. So this is yet another evolution in the AI. So where the evolution of AI is in the United States, where it's kind of heading. So AI is getting smarter and becoming useful very fast. I will show you one example of my personal use. It is spreading in industry faster than anybody imagined. Okay. If anybody tells you that AI will not affect you, that person is essentially wrong. Jobs will change, but it will not disappear. You will need a completely different training in the software industry, and also in the implementation of the AI in your life. As the previous speaker said, for IEEE, there needs to be a much more stronger US rules and national strategy on how we are going to implement this AI strategically in the United States and everywhere in the world, because there is a huge amount of data privacy and all kinds of issues which are critical issues. And government must adapt, will adapt, and our defense network, both here and in India or everywhere in the world, will start using it. So I see Counsel General is not here, but this is for the message of evolution of AI in India. I just read the finance budget of India, and I've been reading finance budget of India since the 12th plan. And the focus of Indian side has to really change. We have been a good workhorse for software writing. We need to shift that thing in the AI world to the software directing. Okay. IT services move up in the value chain, so we should not be in the just software writing business. We have to get into the project management level and design the software. So that will require a massive retooling of the workforce, and in my opinion, India will become the global hub for AI operation. But we should not be really focused on writing software, but we should be leading the software. And there needs to be quite a bit of Indian infrastructure, which I will show you about it, which is at least not in the government's plan for next 5 years. And there will be a public sector transformation. Everything cannot and must not be run by the government. And there has to be investment from the companies in moving this AI forward in India. So in my opinion, India as a developing country must move beyond the human resources that the vast majority of India provides to the Western world and lead this AI revolution, whatever you want to call it. So I picked up just one example just to give you an idea of the scale of the problem. Okay, so India, as I said, the technology is there. You have to just leapfrog it, using it in the Indian context and how to capture the world market. So first question comes in is the infrastructure, and just look at the electricity. You must have heard that at least in Illinois, the electricity prices are going up because everybody wants to build a data center. They build a huge data center next to my house, and Naperville electricity prices going up, they are putting some small. So there is a real problem with electricity. And so just give you a scale, US produces 4 terawatt hour of energy today. And US government is pushing all the mega companies to build their own power plants to keep the cost down. India at the same time produces only 2 terawatts, and per capita we are way below the United States, at least 30 to 50 times below. So building huge data center requires electricity. And we have, as I said, we have to reorient the vast younger generation, both in the United States and India. And major thing for, this is last time I told some of my bureaucrat friends, that protecting data integrity in India is very important. The whole Western world wants access to the data in India, and you will see in the next slide why. And we as a, not me, but as India needs to protect this data for a very vital interest of India. So looking at the energy problem, the green curve is the energy increase, production increase in China over the last 20 years. United States remains almost flat, and India is slowly growing, but nowhere close to China. To take a lead in AI, you must get into some real serious production of energy, and that is roughly, I will say, 50 megawatt per data center that you want to build. And there are technologies that we know we have shared with India under my Fermilab collaboration to get into this a small modular reactor. The India's problem is we don't have uranium. And the government of India just announced a joint venture between NTPC and NPCIL to address this problem. But electricity is only one thing. There are a lot of things, and I don't have time to describe to you all the issues, but this is one thing. So next I wanted to give you the example, because many people think that, or may not have experienced how powerful this AI is. So as I retired last year from Fermilab, I had to switch from my scientific life to doing something else life. And the AI was one thing which I really wanted to see how powerful this thing is. And this is an example of how AI is taking over the software implementation. So I gave my AI desktop a task. And task was essentially write a software that I just gave some criteria, write a software that does my investment planning, manages my portfolio, IRA, Roth IRA, and everything. Okay, it wrote the whole software on itself. I asked it to test it against some other program, and then going through it, and it took me about a couple of months because I don't do things 24/7. And what's mind-boggling is that without writing a single line of code, it produces roughly 10,000 lines of code on its own. It tested the code and produced the output which matches with any investment banker's output. And then I asked it, okay, can you come up with something new? So the blue curve there is any investment banker will show you, and the orange curve there is what AI come up with. And then I validated that thing by looking at the investment laws, and there is nothing wrong with it. So you can see that without me writing a single line of C++ or Python, it produced a web interface software on its own. Just think about its strength, okay? So this thing is just out there, and people are going to adopt it, period. So next thing, which is very close to my heart, is medical science. And this is where most of the AI is going to focus next, or it's already focusing. In the United States, it's a really big focus right now, barring some of the funding cuts of NIH. AI, as you, when you go to get an X-ray taken today, or have MRI or CAT scan, the doctor is not looking at it anymore. There is AI software which goes and looks at it, and then if it finds something, then it tells the physician or radiologist to have a look. And that technology is also improving because they can measure now smaller and smaller pixels. But of course, that's just in imaging technology. First software I learned, which is very good, is diagnostic of heart disease. But focusing on India and Indian data protection is the key reason is India is a very diverse country. North to south, east to west. You cross 200 kilometers, you are in a totally different world. From language, from food, from way of living, in every way you can think of. But we have serious health problems, which are very unique to India. Heart disease, COPD, stroke, diabetes, and cancer. These are the 5 biggest killers in India. And if you try to make a parallel, like most people, well, I shouldn't say most, significant number of people who gets heart disease, the heart specialist will tell you because you're obese, your BMI is higher. India's BMI is very good in India. You know, everybody looks too thin to me. Well, these days they are getting higher. But why we have such a huge heart disease? And these data needs to be collected and analyzed in India, because any discovery that will come from this data should be preserved by Indian companies, pharmaceutical companies, or medicine, rather than this whole world. So the AI revolution has just begun. It's I think 2024 and 2025. I mean, it has begun for the public use. Okay, in the research world and in the computer industry, it has been there for a very long time. Yet the resources are limited worldwide, and including United States. Everybody is talking about data network. Opportunities are there, and it's unimaginable. But we need to rethink and retrain ourselves. Okay, and it's specific to India that policymakers should bring the realism and expertise in this discussion, because you can make a financial plan, you can write a report, but you need the real experts who knows the real things in the pipeline. And infrastructure is the biggest issue when India talks about getting into AI and quantum computing. Thank you. If you have any question, I'll be glad to answer it.
Any question, guys?
Yes.
Yeah. Oh, that's sorry. From here? Or? You have a question? Yes.
I don't think it's working. Can you try?
Yeah, I can relay it back.
We've heard from the speaker.
Yes.
AI is only useful if it creates a business result, risk mitigation, operational improvement, or upskilling of humans.
Yes.
When I hear India talk about AI, you're mostly about the technical side of it, but very little about the other side. What are your personal views about that?
You mean societal impact?
No, I mean business leaders directing their IT departments to implement and do the right business rules so they maintain software integrity that's been in for decades.
Yes, so that's what this slide is for. That most of the business managers, the way I vision it, moving forward will write a project plan or project document and feed it to AI, and AI will generate that project. And we are not far away from that in technology today. So in banking, like say in finance industry, where many of my physicist friends works, it's getting to the level that AI is deciding on your trade. Okay, so I give you finance thing. AI is doing work for Amazon on the floor. It is doing work for Jewel in its inventory. So it's in your life today. I don't know whether I answered your question. Maybe I didn't understand your question.
That's fine. I understand your perspective.
Okay.